Hello and welcome back to Miss Powers Teaches Trigonometry. We're doing trig. Here you go, guys. Let's just do an example today of a question where we're just finding the coterminal, reference, and quadrant. So kind of throwing them all together, all these ideas. And we can sometimes be given these problems like, hey, here's an angle. Find a coterminal angle from 0 to 2 pi. That's a common thing. And which is and then the reference angle, which might be the same as coterminal angle, might not be. And then what's the quadrant? So let's talk about this a little bit and work this problem out. Here we go. Okay. All right. And so the way I like to do these is always, and everything with these trigs, is to sketch out, is to do a quick sketch. Always a sketch first. It's what it makes these so much easier. So we'll draw our axes here, our x and y axes. Here's our y, and then I'm going to draw my x. And trust me, the sketches help so much. Now I got negative 79 pi over 9. Well, shoot. That's how many times around is that, right? How many 2 pi's is in 79 over 9 pi, right? How many pi's, I guess? I don't know. Right? Because every 2 pi we go around again, go around again, go around again. So how many 2 pi's are in there? So let's just make this a mixed number, I guess. Let's do that. So 79 divided by 9, what is that? How many times does that go in there? Well, I think it's 8. 8 at 72. And we got 7 left. So this is really 8 and 7/9 pi, or 7 pi over 9. 8 and 7/9 pi. I guess we could write it like this. That's what we got. So, well, that 8, that's 2 pi times 4, that 8 pi. So I can literally, and it's negative also, we can't forget. Negative. Okay, so what we got to remember then is, hey, negative 8 pi, that's the same as 0, right? Because every 2 pi gets you back to the starting point. So really, I just want to do this angle here is equivalent to negative 7 pi over 9. Negative 7/9 pi, which is more than a half, more than negative a half, but not quite negative 1. So we're in here somewhere. We're in here somewhere. And what I know about this angle right here is, well, since this is negative 7 pi over 9, excuse the awful handwriting, since that is negative 7 pi over 9, this is going to be, right here, my reference angle is 2 pi over 9. And so if I want a coterminal angle from 0 to 2 pi, in other words, in my first rotation of my segment, if I imagine a segment going around here, my angles, I just want this angle here, that one. What's that angle? Swinging it around there. Well, that's going to be pi plus 2 pi over 9. So let's say pi is the same as 9 pi over 9 plus 2 pi over 9. That's 11. That's 11 pi over 9. Great. So guess what? I found my coterminal angle in radians anyway. That's it. I found my reference angle. I did that automatically. That's my 2 pi over 9. And I know my quadrant. As a quick review, the quadrants go like this in order of the angles, right? As angles get larger, the quadrants get larger. So 1, 2, This is quadrant 3 and quadrant 4 right here. So we are in quadrant 3. We got everything we need. We got our answers. Piece of cake. It's too easy. All right, so let's answer our questions now. Now, and this is a fun thing too. If we wanted more coterminal angles, I've talked about this. We can just start adding 2 pi to 11 pi over 9 or subtracting 2 pi from 11 pi over 9, and we'll get as many that we want. So let's see here. The coterminal angle is 11 pi, and I just typed in pi if you're using delta math over 9, which lies in the third quadrant we found with a reference angle of, obviously, 2 pi over 9. That should do it. Woohoo! And that's the way Mr. Powers likes to do these problems. It is not the only way. As we'll probably see here, this is another way. Just keep adding 2 pi until you get a value within 0 to 2 pi. So that was their strategy. Works fine, right? And then everything else is going to be about the same. So there you go. These are always very good for reference, for notes. All right, so thank you for watching that. And until next time, enjoy doing math.